Hey guys, welcome back to another episode of my algorithm challenge. I don't know, remember what day it was. I think it was 51 or something, or 50, not sure. But uh, we talked about doing two pointers problem, and I tried solving a medium level difficulty question. Let me just quickly share my screen to show what I try to do. So yesterday I told you guys that I was gonna do a medium level difficulty question. So I was doing this uh implement tree, prefix tree, but then turns out it was quite difficult to solve. So I was spending quite a time on it and I couldn't solve it. So I decided to do something easier. So that's why I moved back to this question, palindrome linked list. I'm gonna go back to the medium level difficulty question once I figure it out. But for today, I just want to do this one, palindrome linked list. And the logic is pretty simple. Palindrome, like tackled in many other questions, it's basically when a letter of the first letter and the last letter is the same, and then if we iterate through the array, the next index is also the same with the letter that is one index further from the end, and so on and so forth. So it's just the application on the linked list, as you can see here. 1, 2, 2, 1. 1 is same as 1, 2 is same as 2. So it is indeed true from the text case 2. Um, it is false because 1 is not same as 2, right? So it's false. And you just have to return um, the Boolean value, so if it's true or not. So I've used two pointers to solve this question. So there are three things that you would have to do. Um, you would have to first find the middle of the list using two pointers. So uh, the one that's fast, with which moves two indexes at a time, and then one that's slow, which is slower, so it moves only one index at a time. Um, You also have to reverse the second half of the list. And after that, you compare the first half to the reverse second half. First half, you compare first half with the reversed second half. So basically, what you do is um, when fast pointer reaches the end of the list, slow will be at the middle, right? So this works because fast moves twice as fast as slow. And we have to find the middle because the list uh, or the list node has to be divided into two parts in order to be compared. So if the list has an odd number of nodes, the middle node doesn't have to be checked, so it would be the same in both halves. So like let's say um, no, we don't need an example for this one, right? It's pretty clear. Uh, so and then we reverse the second half of the linked list. So we start from the slow pointer, reverse the rest of the list, and then this will effectively reverse the second half of the list. Um, and this should be done by standard in-place reversal, um, by iterating through the array and flipping point the next pointers, as you can see here, right? So that's how you reverse it. Um, so let's say that there's like 1, 2, 2, 1, just like the example. That is not minus, that's just arrow to show that it's a linked list. So we reverse the second half starting from the second two. So 2 to 1 becomes 1 to 2, right? So if we compare that with the first half, then we know that it's true. So this becomes true. Let me just reconnect my video. Well, hopefully, come on, yes. Okay, I fixed it. And now, like I said, we compare the first half with second half after reversing it, and if it fits, then it means that it's true. So let's try to implement that as a code. Uh, so we have to implement the base case as well, the edge case, right? So if not, uh, we check if the list is empty and if there is only one node. So in that case, uh, we just return false, right? So uh, how we do that is by if not head next or not head, then we return true. So the other way around, yeah. So yeah, if there's one node and if it's empty, then trivially it's always true, right? It is a palindrome. So now we have to find the middle, right? So how we do that is by we first initialize a slow pointer, fast pointer, and the head, and while fast and fast done next. Slow, we just go one node at a time, so slow dot next. Fast is we go two steps at a time, so fast dot next, right? And after that, we reverse the second half. So that is done by previous. We initialize the previous node as none, and while it's slow, we temporarily store the next node. So that will be done by next node equals slow dot next, and slow dot next equals the previous. So this is how we reverse it. We looked at it when we were doing the linked list section. Now we move the previous to the current node, right? So that's done by previous equals slow, and then we move on to the next node, which is node. Now, for step 3, we compare the first half and the reverse second half. So left, right is equal to head and previous. And while right, so we only need to compare until the right ends. While no. So if the value of the left is different from the right side, then it means that it's not a palindrome, right? So if left of val is not equal to right of val, and then return false. Yes. So we compare the first half, so the left pointer starting from head with the reverse second half, which is right pointer starting from the previous. So, and then after comparing that, if this passes, then we keep on comparing, right? So left equals left dot next, and right equals right dot next. If nodes in the first and second halves match, then we return true. So yeah, we return true, right? So let's see if this works. Oh, yeah, so it works, guys. Yeah. What will be the time complexity of this solution? Um, it should be O to N because N is the number of nodes in the linked list, and we traverse the list multiple times, but each operation is linear with respect to the size of the list, so that's why it's O(n). The space complexity will be O(1) since the reversal is done in place and there's no additional data structures. So yeah, we use the two-pointer technique to find the middle of the list and then reverse the second half and then compare it with uh, the left half, right? And we did that by using fast and slow pointer and then also initializing left and right. So yeah, that was it. It seemed pretty difficult. We wrote a lot, but the logic itself isn't that hard. Just gonna submit this. I thought what we did do for tomorrow. Oh shit. 79, 93 test cases passed. 1121. Okay, guys, I'm gonna try to solve this tomorrow. Okay, so what we do tomorrow is we try to solve this because it only passed few of the test cases. And also I want to do some pandas for I'm sure you guys all might have heard of pandas um for data manipulation. I've had some data sets from my previous school's courses and also from Kaggle. So I thought it would be interesting and both refreshing our minds from this algorithms. Also, it is very useful. And I think I'm going to use some of, I think I'm going to use pandas quite often in my next um, analyst kind of job. So I thought it would be nice for me to revise them. So I'll prepare some questions and then we can go over manipulating data sets that we obtain from Kaggle. Anyways, yeah, that was it for today, guys. Thank you guys all for listening. And if you guys have any comments, leave it down below. I'll see you guys tomorrow.